Have you ever wondered how your device gets its IP address? It's a little like moving into a new house and getting a new address. Today we're diving into the world of IPv6, the latest version of the Internet Protocol, which is responsible for assigning addresses to devices on the Internet. Two methods dominate this field: SLAAC, or Stateless Address Auto-Configuration, and DHCPv6, the Dynamic Host Configuration Protocol version 6. Both methods have their unique characteristics and uses, much like different methods of mail delivery. SLAAC, for instance, is a bit like a self-service process. It doesn't require a central DHCP server. Instead, devices on the network generate their own addresses using information they receive from routers on the network. Much like a house in a neighborhood with a similar address format, the network prefix, assigned by the router, is the shared part of the address. And the unique part of the address is generated by the device itself. On the other hand, DHCPv6 is more of a centrally managed process. Unlike SLAAC, it does require a DHCP server. This server keeps track of all IP addresses on the network, assigning them to devices as needed. It's much like a homeowners association that assigns addresses to new houses, keeping track of all the addresses in the neighborhood. Both SLAAC and DHCPv6 have their pros and cons. SLAAC is efficient and scalable, eliminating the need for a central server. However, it lacks a mechanism to detect address conflicts, which could potentially lead to issues. DHCPv6, while requiring a central server, brings more security to the table with the ability to track and manage IP addresses. So, what have we learned today? SLAAC and DHCPv6 are two methods of assigning IPv6 addresses to devices on a network. SLAAC is akin to a self-service model where devices generate their own addresses, while DHCPv6 is a centrally managed system where a server assigns IP addresses. Each has its strengths and weaknesses, and the choice between the two will depend on the specific needs and resources of your network. And with that, we wrap up this dive into the world of IPv6 address assignment. Remember, whether it's a new house in a neighborhood or a device on a network, everything needs its unique identifier, its own address. Until next time, keep exploring, keep learning, and keep asking questions.